Let's dive into space mining, our vast cosmic treasure chest. Everything we need to thrive as a civilization until the sun's last glow is right up there. The real question? Where can we find and harness these riches? While it's a daunting task with high costs and risks, space mining is key to our expansion into the cosmos. It might even help save the Earth. The space race is on. We're exploring three key areas for space mining: asteroids, the moon, and planets like Mars. Starting with asteroids, they promise immense profit but come with initial hurdles. Asteroids are like time capsules from the solar system's early days. Some of them are over 1 billion years old. Asteroids are composed of metals, rocks, dust, and gases that didn't merge into a planet. These elements exist in asteroids in a denser, more reachable state. Planetary formation involves intense heat, causing metals to settle at different layers, with the densest forming the core. Asteroids, however, often skipped this reshuffling, leaving large chunks of valuable metals intact. This makes them gold mines in space. For instance, an average metallic asteroid might have 80% iron in an assortment of valuable metals like platinum, gold, and others. Some asteroids even possess more nickel than Earth's crust. What's exciting about this, however, is the sheer concentration of rare metals like platinum, which are scattered on Earth but densely packed into asteroids. Imagine extracting more platinum from a single space rock than has ever been mined on Earth. It paints a picture of a future where we're not depleting Earth, but tapping into the vastness of space. The universe teems with untapped potential, but the challenge is actually reaching these resources. While asteroids are valuable, their exact offerings differ. We need reconnaissance missions to identify the best mining prospects. As with much of space science, we're making informed guesses based on limited info. Today's certainties might be tomorrow's myths. Reaching asteroids is no small feat. While most metallic asteroids lie between Mars and Jupiter, the gap is massive in human terms. Even with our knack for sending large probes deep into space and landing vehicles on Mars, asteroids are a different game. With planets, we can use their gravity or atmosphere to aid our landings. Asteroids don't provide these advantages. Some might have tiny moons or orbit each other, but their weak gravitational pull makes stopping and landing incredibly difficult. Propulsion can help, but it consumes a lot of energy. Plus, we'd need a massive fuel supply to ensure the mission's worth in retrieved materials. Movies like Bruce Willis's might romanticize asteroid landings, but the reality is trickier. Most asteroids are loosely bound rubble piles, not solid rocks. It's akin to landing on a moving gravel bed with risks of sinking into asteroid material. Once landed, mining presents its next challenge. On Earth, explosives can release the desired mineral. In space, such an explosion would scatter resources into the void. We need a precise, efficient extraction method, a puzzle yet solved. The moon, however, holds more potential than an asteroid. While its exploration might not be the most lucrative, it's certainly valuable. Firstly, the moon once had volcanic eruptions. This brought heavy metals from its core to the surface, resulting in a richer cover of iron and titanium. Moon rocks have about 10 times more titanium than similar Earth rocks. These metals are ideal for constructing moon bases, even though their exact significance remains unclear. Secondly, the moon's minimal atmosphere has led to an accumulation of asteroids over time. Each lunar crater houses an asteroid, and remember, asteroids are useful. The moon is also helium-rich, crucial given Earth's helium shortage. Helium, being unreactive, can create a protective shield against corrosion and fire. It's in computers, microscopes, airbags, phones, and nuclear reactors, mainly cooling MRI machines in liquid form. On the moon, helium-3, a rare Earth isotope, is plentiful due to more exposure to solar winds. This isotope could be the key to nuclear fusion. Just a bit of helium-3 has the energy potential to power the Earth multiple times over, if harnessed correctly. Water molecules are not just present on Earth, but have been discovered in the sunlit areas of the Moon's surface as well. This means water exists almost everywhere on the Moon, even in places we didn't expect, particularly in the shadowy, cold craters near the South Pole. It seems water might be abundant. We humans rely heavily on water for our survival, yet taking water from Earth to outer space is not an easy task. It's both tricky and burdensome. When we talk about setting up space stations or building bases on the Moon, we have to think about providing water for those living there. The challenge: transporting it is both costly and slow. Just to give you an idea, sending just 1 kilogram of any material to low Earth orbit is estimated to cost around $10,000. Now, imagine if we could produce drinkable water directly on the Moon for a cost lower than $10,000 per kilogram. It would actually be more cost-effective to take water from the Moon than send it from the Earth. However, mining the Moon for water isn't a straightforward process. One of the biggest hurdles is moon dust. On Earth, erosion is caused by wind and water. It softens and rounds out rocks and particles. This is why beach sand feels soft and gentle to our touch. Moon dust is a whole different story. It's incredibly abrasive, sharp, and unlike any sand we're used to. Remember the Apollo astronauts? Even during their short trips to the Moon, they faced numerous challenges due to this dust. Their spacesuits got torn, their visors and equipment were scratched, and many of their systems got jammed with the gritty dust. The dust even clung to them so much that when they returned to their lunar lander, they breathed it in, causing respiratory issues. Apollo 17's commander, Gene Cernan, once mentioned that this lunar dust would be the primary concern for anyone planning extended stays or operations on the Moon. Overcoming this dust dilemma won't be easy, especially when we consider mining operations. Mining, by nature, stirs up a lot of dust, and on the Moon, due to its low gravity and lack of atmosphere, the dust won't settle quickly. Instead, it could linger around, creating a dust cloud. If we constantly land spacecraft, roam in rovers, and dig in the lunar surface, we might end up creating an ever-present dusty environment. This could be a major problem for future lunar explorations. Let's talk about Mars for a moment. This intriguing red planet has always been a subject of curiosity. Massive dust storms are a natural occurrence on Mars. Luckily, we won't be making them any worse. We've proven our capability by bringing significant machinery back to Earth, like the Perseverance rover. This rover, interestingly enough, is almost as big as a Honda Civic. Mars presents some exciting mining opportunities. Similar to the Moon, we aim for volcanic regions. Why? Because these are spots where metals from deep inside the planet have reached the surface. Take Olympus Mons, for example. It's not just any mountain. It's the biggest mountain in our solar system. In a fun comparison, it sticks out from Mars' surface just like a giant pimple would on a face. Since Mars doesn't have plate tectonics like Earth, its surface remains unchanged. This means Olympus Mons, this gargantuan volcano, has just been there, erupting leisurely for billions of years. And that's just one spot. Mars is sprinkled with many such volcanic areas, potentially filled with precious metals. Mars, like our Moon, has a plethora of craters. These craters are excellent markers, guiding us to asteroid remnants and the treasures they might hold. But here's a Mars-exclusive twist. It once had liquid water. Water acts like a natural cleanser, washing over rocks and taking minerals along with it. This natural movement makes our search for resources a tad easier. Where water once flowed, Minerals are probably bound to be nearby. Heavier minerals usually settle in lower areas, so valleys and basins on Mars are likely treasure troves. Let's dive deeper into Mars mysteries. While many might think of Mars as a barren wasteland, it's not entirely devoid of water. Imagine vast amounts of frozen water just sitting on the Martian surface, like a treasure waiting to be uncovered. This water, once tapped, could play a significant role in our future endeavors on the Red Planet. Given the many opportunities Mars presents, there's a buzzing excitement that mining on Mars might become the modern equivalent of the gold rushes we've read about in our history books. Now, let's imagine we want to start a new chapter of humanity on Mars. Whether we dream of people setting up homes there or adventurous explorers setting up camp for extended visits, there's a lot to think about. Picture this: you're trying to send a gigantic package from Earth to space. Just getting it out of our atmosphere into low Earth orbit is already a mammoth task. Want to send that package to the moon? Multiply that challenge. Now, if your destination is Mars, well, you're in for an epic adventure. It's almost like trying to send all the necessities for a long camping trip in a single backpack. There's just too much to pack and not enough space. This means if we want to live on Mars, we'll need to be smart. We'd have to learn how to make the most of what Mars has to offer, be it turning the frozen water into drinkable water, producing oxygen to breathe, or even making rocket fuel right there on the planet. And Mars isn't just about survival. If we want to make it our second home, we'll need materials like iron, nickel, copper, gold, and titanium to build our new world and the tools to thrive in it. How do you think space travel and digging for stuff in space will change your everyday life on Earth in the next 50 years? Let me know in the comments. Smash that like and subscribe for more.